this is what is it. Let's see. Is it Panayotis? Is it him? Is it what we said yesterday? No, this is. Yes. Awful. Okay. No, we don't. We couldn't do it because we don't have their material on the fork here. Actually, that's a good idea not to. If you don't have a lot of diagnostics, don't try to raise. Because no, this is not what we saved. Yesterday we saved much better.
Yes.
This is what we saved?
I think
No?
no.
Okay. Okay. Let's do it again. So maybe this.
Another folder.
If it's the same, it's disaster.
Worse.
Well, let's see. Let's see, because that's a problem with scan. It's not what we saved, actually. Okay, we'll skip it then, because I will not use it. It's so let's do it manually. So how we can do it manually?
Посмотри. Другое.
Это то же самое. Да, он не убрал самый скан. Of course, it's not that exact, but if it will be the patient where I would see that like almost 0 degrees, like close to 1, we can do that. With Panayotis, it's not a very good idea to do that. So, and actually that's why I'm doing the loading of the models during the appointment. Okay. So it's not the best, but at least something. Maybe actually we're much better with the fork because I don't like this inclination. But actually remember that was like 3 or 4 degrees. If you remember, that was in Panayotis case even 5 degrees. That might be pain. So that's, we have to download the computer tomography. So, and I put it on a desktop. Where is it? So with computer tomography, it's better when it's only one DICOM file. It makes life easier. But if there are many DICOM files, I can't show it here right now because it's one DICOM file. It's better to go back and to click on the folder where all these DICOM files are present.
The zip file.
No. It has to be unzipped. But for example, an unzipped file, there is file images. And you go on this file and there are numerous DSM DICOM files. So if you see this list of DICOM files, you go back to the images and you press on images, and it will just make one file from these numerous files. Like I'm doing here, you see, it's only one file here. and it's quite heavy. It's good. And there are windows here, the sliders, to adjust their view. The contrast is better to be not more than 500. So it's too much. But so pleased to meet you, Panayotis. And there are different ways to see the picture. This is standard grayscale. We never use it. Tissue fixed. This is a better view. There is also here isosurface. Isosurface you would use when you need to place points on soft tissues. And also there is X-ray mode. X-ray mode we'll use just to see the joint, the condyles. But for 90% of our work we use tissue fixed. And here I can tell you guys, this is the best quality CBCT that I have in this program. So whoever did this CBCT really knows how to remove the noise and to take away all the scattering that is in the X-ray. And that's very important because the less noise, the quicker would be the analysis. For me, the most time would be to match the points, and you'll see that. So right now, we have here axiography. We have models, more or less aligned manually on the fork. We have CBCT. And we can perform what is called complex diagnostics. So we go to diagnostics again. If we go to the complex diagnostics, which is in the first row, create. And then we'll see the boxes here, and we can choose what we'll use in diagnostics. So today, we're gonna be everybody, dentists. So we'll use all the axiography, we'll use position diagnostics, we'll use individual models, and computer tomography. And just not to forget, because sometimes you will do very easy diagnostics. So we'll put axio plus models plus CBCT plus position diagnostics. So right now I know this is the most comprehensive analysis I could have in this system. And we press OK. What irritates me in this program that it never shows you that it's thinking. But I hope they'll try to solve it in next, because everybody complained about that. Because sometimes what happens, nothing happens, you start to panic. So this is called 2D view. 2D view is like you see this graph and a grid with the trajectories. This is called 3D scene. Why it's important to know? Because if you're going to watch, for example, the promo videos, for you it will be easier to understand what, for example, the speaker is talking about. So 3D scene is when they see the 3D object. 2D view is when they see the grid and the trajectories. So here, axiography, as I told you yesterday, looks like a pale eye. So, but it is not so. So if you don't want to have axiography,